This question is a general discussion on YDSE in which we are given a double slit which is illuminated by a coherent light and the interference pattern is observed on the screen. In this particular variation, we are changing the width of the slits without changing the suppression between them, and we are asked to discuss the effect of this change on the fringe width or the intensity of the fringes. Alright, so let's start a discussion. Let's say we are talking about the fringe width. We know that the fringe width beta is given by d lambda by d. This is the fringe width which is given by d lambda by d. D is the distance between the double slit and the screen. Lambda is the wavelength of the light which is illuminating the slits, and d is the separation between them. And we are told that we are only the width of the slits is changed without changing the separation. So we can say that since none of these quantities are changing, beta will not change. That is, the fringe width will remain constant. So in this case, there is no change on beta. There is no change on the fringe width. So there is since all these quantities are constant. Now let's talk about the intensity of the fringes. Intensity of the fringe depends on how much amount of light is entering from the slit. Now, since the width of the slit is increasing, the amount of light entering the slits will increase, and thus the amount of light reaching the screen at a particular point will also increase. Now, if the amount of light increases, the intensity of light will also increase. But that is not the only effect that is going to occur, that is the intensity of the fringes. But intensity will increase, but with that there will be some overlapping of the fringes as well. So overlapping increases, that is the intensity will increase, and there will be the clear demarcations between two fringes will cease to exist. So this effect can be said that the increases intensity increases, but overlapping occurs and thus the interference pattern becomes blur. So we cannot clearly distinguish between the two different fringes. Alright, so that was one of the discussions. There is another sort of variation in YDSE, where this is the setup for a YDSE for a red light, wherein this is the source and this is a filter, red filter. So the light which is coming in, that is monochromatic, which is illuminated, the single slit is illuminated here, and the double slits, since they are illuminated from the same single slit, we can say that these are coherent sources, and this is the screen. Okay, so this is setup, and in this setup we are asked in the first question that if the red filter is now replaced by a blue filter, we are supposed to explain the change in appearance other than the change in color, obviously, the color of the fringes of the screen. So now, since if we remove the red filter and instead use a blue filter, the light which is illuminating the slit, the light will change, or the wavelength of the light will change. Now the wavelength of the light will change, and thus the quantities which depend upon the wavelength of the light will also change. As a matter of fact, we can say that the fringe width, which is given by d lambda by d. Here, this capital D, that is the distance between the double slit and the screen, that is not changing. D, that is the separation between the slits, that is also not changing. Lambda will change. Now, the lambda for blue is different than lambda for red, hence the fringe width will change. We can say that lambda for blue is less than the lambda for red. This implies that the fringe width for blue will be less than the fringe width for red. So the fringe width decreases. That is one thing. And also, since the wavelength is changing, so the order of maxima or order of minima that we can observe on the screen, that will also change. Since wavelength is decreasing, the number of fringes or the highest order maxima, that will increase. So the effect is fringe width decreases and thus the number of fringes increase. So the number of fringes increase and the fringe width decreases. Now the second part is, in this part we remove the filter at all, and thus we are supposed to explain what will the interference pattern be like on the screen. Now, if the filter is removed, there is white light which is coming in. Now, if the white light is coming in and it is interfering on the screen, we can say that the central maxima which will be formed here, that central maxima, which is midpoint of the two slits, that central maxima will act as a maxima for all the wavelengths. Thus, all the lights will have a maximum at this central maxima or at the center point. So we can say all the lights, they have maximum intensity. So the color of the maxima here, that will be white. But as you go up from this point, or we go below this point, so above and below, there will be points where, let's say, red has a maxima but blue does not, or the other colors do not have a maxima at the point where red has. So we can see different colored fringes. Above the central maxima and below the central maxima, but the central maxima will be white in color. So we can say the central maxima is white in color. The central maxima is white in color, and other parts are a mixture of different colors. So that was the discussion on YDSE. Thank you.